Hi, welcome to my video on defining the eccentricity of an ellipse in a circle. This is the first video in the new unit on conics of the circle, ellipse, parabola, and hyperbola, but it's done from the point of view of the focus. I did a previous unit in Algebra 2 on the circle and the ellipse and the hyperbola, but it was only done from the center, which is whatever point the center is going to be, but I didn't use foci, so I wanted to do this unit based on using the foci. So let's start our video. We're going to define eccentricity of an ellipse and a circle and see if we can build it up and help you understand how it's all done. Eccentricity: how much a conic, circle, ellipse, parabola, hyperbola varies from being circular. So eccentricity is going to be a ratio. I'll discuss that coming up. So what we have is we could have a point here, which we'll call x1, y1. We have another point over here, which we'll call, okay, let's call this one x1, y1. And this one is x2, y2, only because this is the first one, that's the second. And if you take those 2 points and get the center of those 2 points, let's assume that these 2 points are equal distance. So this distance right here is the same as this distance. So this is the middle of these 2 points, which we're going to say the center is 0, 0. And that center is actually the midpoint, which is found by adding up the x's and dividing by 2, and adding up the y's and dividing by 2. So the midpoint of these 2 points is the center of this horizontal segment right here. So let's look at it further. So let's call this point right here a vertex. I'm going to call it vertex 1, and I'm going to call this point over here vertex 2. And I'm going to use a blue to represent the vertices. I'm going to use the blue that's on this pin and do my vertices in blue. So if you take the distance from here to here and you call it a negative A, and you take the distance here to there and call it A, then the coordinates of this point right here is negative A, comma 0, and the coordinates of this point here is A, comma 0. And notice A is negative on this side, positive on this side. But the length of this segment, and length is distance, the length is A add on A, so the length is 2A. So from right on through, from there to there is 2 times A, because the length is always positive. So it's 2A. Now, let's change it. I'm going to use my foci in red. So let's call this point here F1 for foci 1, and call this point here F2, which is foci 2. And so the vertices are A units to the left and right of the center. The foci are C units to the left and right of center. So from here to here is negative C, and from here to here is C. And the length of the foci, length, is twice C. Again, you can't, this is whatever this value is here, let's say this is a 4, then that's a negative 4, but the distance is twice the value of C because the distance is positive. You can't say the distance is twice negative 4, say, but you give a negative 8. So the length from here to here is, So from there to there is twice C, 2C. Okay, let's look at an example. And the example I'm going to do is down below. Let's take that vertex 1 and vertex 2. Again, the vertices I'm going to put in blue. So this one right here is a negative 4 units to the left of center. And this one here is 4 units to the right of center. Okay, there's distances. So that means the length of the vertices, or the points, we're going to call them vertices, points are the length of that segment is 2 times A, so that's 2 times 4, so the length of that segment from here to here, from one vertex to another, is 8. And let's do the foci now. So notice the foci are the vertices are further away from the center, the foci are not. So, let's go back. I didn't put the coordinates at that point there. So this is negative 4 distance, so this vertex is a negative 4 comma 0. And this vertex here is 4 units to the right, so that's the point 4, 0. Okay, change the pen. So now we have foci 1 and foci 2, and the foci are less away from the center, so the foci, let's say if that's a negative 4, let's make this one a negative 3. Now I could have negative 2, negative 1, negative 1.5, negative 0.5. I could have any value, but I elected to take a 3 because 3 is less than 4. So that means that the coordinates of this point right here is negative 3, 0. The coordinates of this point is 3, 0. So C right here is negative 3, and C right here is 3. So the length of the segment joining the foci is 2 times C. So that's 2 times 3. So that's this distance from this foci here to here is 3, and 3 makes 6. Again, when you're doing distances, you can't say 3 plus negative 3 is 0. You have to do the absolute value. So that's a 3, and that distance is 3, so it's a 6 in total. Okay, let's continue. So notice the foci and the vertices are on the same line. That's important that when we explain this topic on the conics of ellipse and hyperbola and things like that. So let's look at what we call the eccentricity. So the eccentricity is, I'm going to spell it out. The eccentricity is denoted by the letter small e, but I want to distinguish, but it's not the E, which is 2.718281828 being an irrational, is not the E that's in compounding. It's not the E that's in compounding interest continuously. Just want to make sure it's compounding interest continuously, or it's not in what we call the log of x base e. So this e that's in compound interest and the e that's in a log is this number here, 2.718281828 repeated, but this e is the eccentricity. And the eccentricity in the conics, the e is the c over the a. So the eccentricity is a ratio. It's the distance. C is the distance. C is the distance from the center to the foci. So C is half of this distance. So from the center to this foci is C. The distance from here to here is C. So C is the distance from the center to a foci. A is the distance from the center to a vertex. So this distance is A, this distance is A. So let's continue. Now I'm going to do more. So to explain it, I'm going to set up, I have a graph set up. Allow me to put this graph down here, and let me show you. I have to put this graph in place to make it, to show that it's, and I'm going to move the screen a little tiny bit. If I can. Oops, why not? Move the screen. Okay, there it is. So you can see what I'm doing. Okay, I have it adjusted. Now, what I'm going to do is show you how the ellipse, where the ellipse comes from, or how it's drawn. So I'm going to take the previous first of the video. I had foci, and I marked the foci. I marked the vertices, V1 and V2, with, I said, blue ink. So that was done that way because these markers here, these pegs that I have, are in blue. So this vertex here is -4,0, and this one is 4,0. So what I'm going to do is, I'm going to take that away now. I'm going to put a line stretched out here and marking them, putting the, now gets it down through that hole. There it is. Trying to explain, just takes a while. Notice the markers are at, again, 4. That's 2, 3, 4. And this one is -2, -3, -4. So the vertices are at 4 and -4. So if I take, yes, the vertices are blue at 4 and -4. So let's put the foci at 4 and a -4. So what I did, I drilled a hole down through here, and now I'm going to drop this pin, which is representing the foci, and I put this one here representing the foci. So remember, the blue is the vertices, and the red is the blue is the vertices, the red is the foci. So notice I have a string going along here, and this string, this string got a gap here because of the width of this peg that's here, the metal on the peg. But really, this, if you think about it, allow me, oops, got to try to keep it steady. I'm going to write on this now. What happens here is that, I'm going to write right here, the eccentricity is the C over the A. So the C is that the distance that from the center, from here to this red one, which is the foci, is 4. And the distance from the center to the vertex is also 4. So that means the ratio is a 1. So the eccentricity that here is 1. But notice when you have a 1, you have a line, which means you have no ellipse. So let's continue. Let's move this out of here. Now I'm going to move, apologize for the rotating there. Now I'm going to move the foci. Instead of at 4, I'm going to move them to 3.5 each. So here we go. So I'm going to pull this one up and move it at 3.5. I'm going to pull this one up and put it down at 3.5. Now the foci are 3.5 units to the right and 3.5 units to the left. So this point right here is 3.5 comma 0, and this point is a negative 3.5 comma 0. So as a result, this string is looser. Watch. This string is looser, so I'm able to move. Let me get that. I got a knot right here. I want to make sure I rotate this. So watch what happens. So as I stretch this out, here I go. So it's going around. So notice now. Oh, keep her going. As long as I don't. Going down. So notice now, I have an ellipse drawn. It's an oval shape. So in this ellipse, C is the foci distance. The foci distance is 3.5. Oh, I got eccentricity is C over A. I better be careful. E is C over A. That's 3.5 over A, and A was 4. The A is always going to be 4 when I draw all of these. So that gives us a ratio of 3.5 divided by 4 as 0.875. So when I keep the foci at 4, which I have right here, when I keep the vertices at 4 and change the foci to move closer to the center of 0, 0, you will see. Let's see what's going to happen. So now I moved it to 3.5. What about if I take the foci and move them to 3? Here we go. I move them into 3. Both of them are at 3. This is at 3, 0. This is at negative 3, 0. And now allow me to draw the ellipse again. So notice this time it'll spread out further. Here we go. Here it is. Spreading out further. Notice the ellipse. Okay. Oh. There it is. Oh, got away from me. Okay. Now what do I have? On this circle, the eccentricity is, again, the C over the A, and C is the distance from the center to the foci. So this time it's a 3. It's 3 here, negative 3 here, so the distance from the center is 3, and A is 4. So 3/4 is 0.75. Boom. I'll keep going. I'll keep going. Now I'm going to put the foci at 2. There's 2, and there's a negative 2. So I made the foci, and there it is, 2, 0, negative 2, 0. So C is 2 this time. Now I'm going to draw my, again, you can see there's going to be an ellipse. So as a result, the closer I get to the center, this line, or the segment, or lines, will move further out to, notice. And the eccentricity for this circle, E equals C over A. Eccentricity is C over A. C is the distance from the center to the foci, which is 2, all over 4. Remember, we're keeping A to be 4 vertices of 4, negative 4, constant. So that gives us a 0.5. Okay, let's do it again. Now, what happens as if I kept going in, I could do 1, but what I'm going to do now, I'm going to take the 2 of them and bring the 2 of them in and put them at 0. So they're there. The two of them now are at 0. That means that the center, the foci, are at 0. So if I take this off the top just for a second, and I leave the line there, let's see what happens when I take the foci, in this case, and put both of them at 0. So now we have it stretched out. Here it is. Now I'm going to draw. And you might look and say, when you look at this, look at it, what you see is hitting at 8, -8, 8, -8. So moving the two foci at center 0, 0, which means E, which is C over A. The foci distance is 0. A is still 4. Notice when I stretch this out, okay, notice when I stretch this out, this distance from here to here is 4. Or from here, half of it. Remember when we started, I moved it like this. I moved it from 4 right here, from 4 to a -4 right here. That means that was 8 long. So when I stretch this out like this, I'm making this segment 8 units long, which was at the beginning. I'm making this the radius of a circle. This is a circle. Notice the distance is 8, 8, -8, 8. So the radius, this is a circle whose radius is 8. So when the foci have no distance from the center, we end up with a circle. Okay, let me move that away. Take this away now. I'll probably bring that back for a quick review. So, the eccentricity is E equals the C over the A. So when we had the eccentricity of 1, that the line went from here to here, and the distance from the center equaled the foci distance. So the foci distance from the center and the vertice distance from the center, they were equal, because that gave us E equals C over A, which would give us the 4 over 4, which gave us a 1. So if we have the distances from the center with the vertices and the foci the same, we get a 1. That means we got a line. We didn't get an ellipse, we didn't get a circle, we just got a straight line. And also notice, again, bring this diagram back. Here we go. Put it down. Notice as the value of, remember, C is 4. As the value of C decreased and went to 0, this is oval, this is less oval, and again, this one right here is when it's at 2. Notice it's less oval, it's getting more like a circle. So when we hit it at 0, when the foci distance was 0, the two foci are at the center 0, 0 right here, then it became a circle. So, bring it back. So what we have, if the value of E, eccentricity, if the value of E is between 0 and 1, then we have an oval shape. But the oval shape, if we approach 0, we approach a line. If we approach 1, we approach a line. If we approach 0, we will approach a circle. So in between, it will be oval. But if the eccentricity, when the two foci are at the center, the eccentricity is C over the A, 0 over whatever A is, then you get a 0. So when the eccentricity is 0, we will have a perfect circle. So that's explaining how the eccentricity works in relation to two vertices and two foci, the distances from the center. Hopefully you'll understand what I just did, and hopefully the video helped you understand about the eccentricity in terms of the foci distance and the vertice distance. Thank you for viewing my video, and if you did view it, click on the like button if you like it. Click on the subscribe button if you want to be a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, which is just one word. Okay, thank you for viewing my video. Hope the video was of some help to you. Bye-bye.